So hi guys, module 4.4, this is about transformations of linear functions, and this is a pretty big unit. So let's see, I might break the video apart into 2 parts or 3 parts so that it's like not too much. So let's look at our learning target. I can apply translations to linear functions, apply dilations to linear functions, apply reflections to linear functions. So let's see, I might do translations in one video, I might do dilations in another, reflections in another, or I might just do dilations and reflections on one. So we'll see how it goes and how long the video is just on translations today. Okay, so when we are talking about transformations, I wanted to look at the 5 things that we are going to have when we have a transformation. Okay, so what a transformation is basically, we are moving that a line which has been graphed on the coordinate plane, and either it can move up or down, or it can shift from side to side. Okay, and so that's what is happening in transformations. So there are 5 different types of transformations that I would like you to look at. The first one is a horizontal translation. Okay, so horizontal, basically if I have a line, it is moving either this side or this side. Okay, so that's a horizontal translation. If it's a vertical translation, it is moving either up or down. It's moving either up or down in the coordinate plane, and that's what a vertical translation is. And then we have the horizontal stretch or shrink, and we have a vertical stretch or shrink. And both horizontal and vertical stretch or shrink is nothing but dilations. And in this, the graph is getting steeper, or it is not going to be that steep. Okay, so it is a shrink or it is the stretch. And then the 5th kind of transformation is reflection over the x or the y axis. All right, so these are the 5 different types of transformations. So today I am going to focus on these 2, and then I'm going to see if the video gets too long, and then I might put this on a different video. All right, so let us begin by talking about some key vocabulary terms. So today I am going to focus on translations of linear functions, and we are going to apply translations to linear functions. So the first thing I would like you to understand is the vocabulary of certain words. Okay, and let's look at what the parent function is. But before I get into the parent function, I would like you to understand the family of graphs. And what is a family of graphs? It includes graphs and equations of graphs that have at least one of the characteristics in common. All right, and then if we have the parent function is the simplest of the functions in a family. So once again, in math, a parent function is a function from a family of functions that is in its simplest form, meaning that it has not been transformed at all. So there are a couple of parent functions, and I have gone ahead and I have just written it out, and I'm going to show you what the graph looks like of these parent functions. All right, so the first one I would like you to look at is the constant function. Please remember that f of x is nothing but y. Okay, so in this, y is equal to k. So let's say my constant is 5. So in this graph, I am just going to have a horizontal line. So if this is my graph over here, my x and y, and so let's say I say that my k is equal, or y is equal to 5. Okay, if I say y is equal to 5, then let's say this is 5 over here, okay? This function is going to be like this. All right, so this is the line. That is my constant function. If it says that y is equal to 9, it will be a straight line on 9. If it says y is equal to -3, it will be at -3. All right, and that is basically what the constant function is, and that's the parent function again. And so f of x is equal to k is, this is the line of your constant function. Now, the linear function. This is the one which we are going to be working on today. And in this, literally, I'm going to have a graph. And it's saying y is equal to x. So if you think about it, if I had made a table, if y is equal to x, if I'm saying, I'm just going to make it here so you can see what I'm talking about. This is x and this is y, which is what? F of x, right? So if I give some values and I say if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2. So what is happening in the linear function? It's nothing but a straight line, and the value of f of x, which is y, is the same as x. So in this, my line, literally, if this is 0, 0, this is 1, 1, it goes like this. Okay, so this is the parent function of a linear function. This is the simplest form of it. All right, then let's look at the absolute value function. So in the absolute value function, this is what the graph looks like. Okay, so I have my x and y coordinates. So the absolute value of x, y is equal to absolute value of x. So it literally, we know that -2 and 2 have the same distance from 0 on the number line. We know that -4 and 4 have the same distance on the number line. So in this, the graph looks like this. It looks like a V, and the vertex actually stops at the origin, and this is the graph of an absolute value function. F of x is equal to the absolute value of x. All right. Then we have the quadratic function. Okay, and the quadratic function, this one over here, okay, it's saying f of x is equal to x squared. So we know that y is equal to x squared. So this graph looks like this. So this is not as straight like the absolute value one. There's no vertex, more like a parabola. It's going like this. So this is my quadratic function. And then I have the graph, the square root function, and this goes in this format. Just going to show you so that you can know to identify the graphs if you ever see it. And in this, y is equal to square root of x. So this graph looks something like this. All right. And then the last one is the inverse function, and in this the graph looks like, all right, we're going to have something like this, and then it's going to look like this. Okay, same thing but here. So this is the graph of an inverse function. So these are basically, once again, the parent function is the simplest form of functions in a family, and I just showed you some graphs of the parent functions, which are constant, linear, absolute value, quadratic, square root, and inverse. And today we are going to focus on the linear function. Okay, so let me quickly show you the parent function f of x is equal to x in a linear function. All right, so I know that f of x is nothing but what? That is my y. So this is y is equal to x. So if I was to create an input-output table, okay, and I said, this is x, this is f of x, which is nothing but y. This is y, right? So if I say my x is 0, this is 0. If x is 1, this is 1. If this is 2, this is 2. If this is 3, this is 3. And then the same thing. If it's -1, that is -1. So when I actually graph this, I have my coordinate graph. Okay, and here's my origin. 1, 2, 3. 1, 2, 3. -1, -2, -3, -1, -2, -3, etc. So look what it's saying. If x is 0, y is 0. So there's my ordered pair here. If x is 1, y is 1. If x is 2, y is 2. If x is -1, y is -1. If x is -2, y is -2. So as you can see that what is happening, this is a line that is going straight like this. There is my linear equation. And so this is the simplest form of a linear function, and that is why this is called a parent function. Okay, now I want to quickly talk to you about a vertical translation. So let's look at vertical translations of linear functions. Now, when it's saying the graph of g of x is equal to x plus 8. So when you're looking at g of x, k of x, j of x, I don't want you to be confused. That's basically another form of saying f of x, but because it is a different line, and that is why they are just renaming it. Instead of f of x, they're calling it g of x. So let's look at the vertical translations of linear functions. So the graph of g of x is x plus k, which is the constant, is the graph of f of x is equal to x translated vertically. What this basically means, if k is greater than 0, the graph of f of x is translated k units up. And if it is less than 0, it is going to be translated so many units down. So let's talk about what this actually means. So if I take you back to my board, and I'm just going to show you one of them. So look, I have g of x is equal to x plus 3. So this is basically again f of x, but because it's a different line, it is written in that format. So if I'm saying x plus 3, so let's go ahead and do the calculation what this means, okay? So it is saying g of x is equal to x plus 3. So I am going to go ahead, what do I see over here? I see a vertical translation which is up 3, because the original thing is what? fx is equal to x. So what is the constant that we are adding to that f of x now? We are doing the plus 3. So if I were to make another table for this, okay, I'm just going to say g of x is equal to x plus 3, and I am going to make a table for this. I am just going to write over here, this is x and this is g of x. All right, and so I can see if this is 1, if x is 1, 2, 3, etc., what is g of x? It's going to be 1 plus 3, 2 plus 3, 3 plus 3. And that's how I'm going to get my g of x, which is nothing but the y, right? And so let's see, what is 1 plus 3 is 4, 2 plus 3 is 5, 3 plus 3 is 6. So now, what are my ordered pairs? My ordered pairs are 1 and 4. So I'm going to go ahead and I'm going to graph this so that into the same graph so you can see what I am doing. So this is 3, 4, 5, 6. Okay, so it's saying when x is 1, y is 4. So when x is 1, y is 1, 2, 3, 4. Here. Okay, when x is 2, y is 5. So from 2, this has gone to 5. When x is 3, y is 6. So let's look at this now. Okay, and so when x is 0, y is going to be 3. So now let's look at this graph. Here. Okay, so that is the new graph. So if I look at the distance between these from 0 to 3, from 1 to 4, from 2 to 5, from 3 to 6, what do I see? That all of these have gone up by 3, and that's what this function is telling me. It's plus 3. So this graph has translated vertically up because of the plus 3, and that's what this means. It's pretty easy. Okay, so this is so if I'm saying x plus 3, what is this? This is a vertical translation up 3. So vertical translation up 3. What do you think is going to happen here? So I look at the constant. What's the constant? It is plus 2. So this one is a vertical translation up 2 because it's plus 2. So same thing, vertical translation up 2. Okay, let's look at the next one. If it's saying minus 4, what is going to happen to this graph now? So if I do x minus 4, where is this going? Is it going up or down? Because it's minus, this graph is going to be going down. Okay, so this is also a vertical translation, and this is going to be down 4 units. So down 4 units. So the entire graph is moving down 4 units. Just like this was moving up, that is moving 4 units down. Okay, let's look at this one. This is also a vertical translation down. How many units now? Minus 10. Down 10 units. So this is basically what vertical translation means. So I just wanted to plug those values in for it to be clear to you as to what vertical translation means, up or down. So we are going to look at some more examples. So let's look at this one. Describe the translation in g of x is equal to x minus 2 as it relates to the graph of the parent function. So once again, what is a vertical translation? When a constant k is added to a linear function, the result is a vertical translation, and the y-intercept of f of x is translated up or down. F of x is equal to x. All right, so if I'm looking at this and I'm going to create a table. So if I create this table, I am going to give some values to my x. Okay, so let me give 3 values. And so if I say x is negative 2, and I have x is equal to 0, and I have x is equal to 1. So these are some of the values. So we know that in the parent function, f of x is equal to x because y is equal to x in a linear function. And so if x is negative 2, my y is negative 2. If x is 0, y is 0. If x is 1, y is 1. Now the next thing it is saying that f of x minus 2. F of x minus 2. So what is negative 2 minus 2? I get negative 4. This gives me negative 4. What is 0 minus 2? I get negative 2. What is 1 minus 2? I get negative 1. So what is my ordered pair now? Which is x and g of x, which would be this. Okay, so when I plot the ordered pair, I get negative 2, negative 4. And then I have my next ordered pair, which is 0, negative 2. And then I have 1 and negative 1. So these are my ordered pairs. Now, the constant k is not grouped with x. So k of x, the output or the y values. The value of k is less than 0 because this is less than 0. So that is why the graph of f of x is translated 2 units down. So if I was to graph this, and let's do that really quick. So I know in the parent function, we have 0 is equal to 0, 1 to 1, 2 to 2, and that's how I am getting my linear function. Okay, I'm going to use, so this is my f x is equal to x, this line. That's my parent function. All right, now let me use what I just calculated. I'm going to use a different color so you can see. So based on this calculation, g of x is equal to x minus 2. I have negative 2, negative 4. So negative 2 and negative 4, which is here. Okay. And then I have 0, negative 2. I have 0, negative 2. I have 1 and negative 1. 1 and negative 1, which is here. So look how this graph is going. Okay. So if I look at this graph, how many units down has it gone from here? This is 1, 2. This is 2 units. And from here, it is going down again. Look, 2 units. From here, 2 units. So basically, that's what this is. And I haven't drawn it the straightest. I apologize. Okay, but as you can see, the graph is going down 2 units. And that's what this is because it's not grouped with x over here. Okay, because it's not grouped with x, so it k of x the output or y values, and so therefore the graph is translated 2 units down. So let's look at this one. The graph of g of x is equal to x minus 1 is a translation of the graph of the parent function 1 unit where. So if I look at the top part, it's saying describe the translation in g of x is equal to x minus 1 as it relates to the graph of the parent function. So where is this going? Because the constant is what? It is negative. It is number less than 0. So therefore this is going to go 1 unit down. So we just talked about vertical translations where the graph is moving up or down. Okay, based on whether it is greater than 0 or less than 0, the constant, it is going up or down. That's how it is shifting. All right, but in a horizontal translation, it is moving either left or right. So the biggest difference between a vertical and a horizontal translation is in a vertical one, it's not grouped within the parentheses. But in a vertical, that's in the vertical one. But in a horizontal, it is grouped within a parenthesis. And we're going to solve some problems in a minute so you understand why it's moving. Now this one is a little tricky because if I'm looking at the graph of g of x is equal to x minus h, and when you're saying minus the constant, automatically you start thinking that, okay, since it's minus, I need to move to the left. But in horizontal translations, if there's a minus, the graph moves to the right. If there's a plus, it moves to the left those many units. But, so look over here, if h is greater than 0, the graph of f of x is translated h units right. And we'll talk about that in a minute. If it's less than 0, the graph of f of x is translated absolute value of h units to the left. So, for you to have an understanding of this, let me quickly explain this on my whiteboard. So let's look at my board, and I wanted you to see the difference between vertical translations and horizontal translations. Okay, so we've already done vertical translations, and look at the difference. So if I have this and I have this. Now, I don't want it to be confused once again by what is g of x, h of x, j of x, k of x, l, m, n, p of x. That is just a different function. It's going to have a different graph. And that is why we are not saying f of x, even though it actually means the same thing, but it's a different graph. So they've just labeled it by a different name. So I don't want you getting all confused by all these alphabets that you're seeing on the left. Okay, so look at the vertical translation. We had the f of x, which is my original linear function, right? And is equal to x, and that's what it is. But now we just added a constant. So if I do plus 3, I just showed you it's going to move up 3, right? Vertically. If I'm going to add 4, it is going to move up vertically 4. If I'm going to do minus 6, it's going to move down 6 units vertically. If I'm going to say minus 10, it's going to move 10 units down vertically. So as you can see, all that is going on here is the constant that has been added or subtracted over here. But basically it's added. It's like plus minus 6, right? Plus negative 6 or plus negative 10. So we've added this constant which is changing my output or the y value. And that is why my graph is going up or down vertically. Okay? Now, in a horizontal translation, look at the difference. These are now grouped within parentheses. And that's what's making the change, okay? Over here, there is no grouping. So the grouping is making the change. Now, biggest thing I need you to remember is this. I know when you're looking at plus, you are automatically thinking that this graph needs to move to the right. But not in horizontal translations. It's going to move in the reverse direction. And so if I'm seeing x plus 4, this graph is moving left. It goes in the opposite direction. So this is moving left 4 units. This one. This is moving left 4 units. So please remember, it's the opposite of what you're seeing. And we're going to do some problems so you understand why. Look at this one. M of x is equal to x plus 3. Once again, it's within the grouping. So this graph is going to be shifting left, okay? Because they have the plus, and the opposite of that would be minus is going to go to the left. So this is moving left 3 units. Now look what I'm seeing. I have n of x is equal to x minus 2. Automatically your brain is thinking minus we are going to go to the left. But as I told you, horizontal translations go in the other direction. So if this is saying x minus 2, this graph is moving right 2 units. And then let's look at this one. P of x is equal to x minus 8. Again, because it's minus, it's moving in the opposite direction. So this is moving right 8 units. Okay, so that is what horizontal translations are. Now, once again, in this one, this is a vertical one. All over here, what's happening? This is moving up 3 units, up 4 units, down 6 units, and down 10 units. What's making the vertical and horizontal translations different? It's the not grouping and the grouping that has changed the entire shift, either vertically or horizontally. So that's the first thing I want you to be able to identify when I show you some problems now. So let's look at this problem. It is talking about horizontal translations of linear functions. And I just showed you that horizontal is moving either left or to the right, and vertical is moving up or down. Okay, so it's saying describe the translation in g of x is equal to x plus 5 as it relates to the graph of the parent function. So I've just gone ahead to save time. I've started creating a table, and I have created the graph of the parent function where y is equal to x, or fx is equal to x. Okay, f of x is equal to x. So because f of x is equal to x, the function of x minus h, where h is going to be negative 5. All right, so when I do negative 5, this is basically what it means. Okay, so if I say x plus 5, here we go. I'm going to give some values. And let's say I give myself negative 2 is one of the values that I want to put as an input for x. And I'm going to say 0 and 1. 0 and 1. These are the values that I am giving myself. Okay, so what is negative 2 plus 5? What do I get? So negative 2 plus 5, and this is going to give me 3. What is 0 plus 5? I'm going to get 5. What is 1 plus 5? I'm going to get 6. All right, so the f of x plus 5, f of x plus 5 is going to be here 3, 5, and 6. And then let's look at my ordered pairs of x and g of x, which is negative 2, 3. This is 0 and 5. This is 1 and 6. Now I'm going to go ahead and graph this. Okay, I'm going to graph this. So let me use the color orange, or let me use green. And if I'm saying I have negative 2 and 3 here, negative 2 and 3. And then I have 0 and 5, and I have 1 and 6. So I have 1 and I have 6. So look at this graph now. So if I extend this graph, look, and this is, sorry, it's not straight, but this is what the graph looks like, and it has moved 5 units to the left. And that is why even the function is g of x is equal to x plus 5 within parentheses, we can see that it has moved 5 units to the left. And that is what I mean when I said that you see plus, you move to the left. You see minus within parentheses, you are going to move to the right. And we are describing the translation in g of x is equal to x plus 5. And we saw that when I plotted this, what happened? The entire linear graph moved, instead of, like, you normally think that x plus 5, it should be moving to the right. But no, it moved 5 units to the left. So see, from 0 here, it went 5. So wherever you look from, it's going to be 5 units to the left. So look at the last problem, and the last problem is telling me that g of x is equal to x minus 6 within parentheses plus 3. So when I have that, I can already see, since it's saying minus, even though my brain is thinking it needs to go to the left, it's actually going to go to the right. And the reason why it's shifting is because it's within the parentheses. And then we are looking at plus 3. So this is telling me that it is going to go up 3 vertically. All right? So let's look at this, and we are going to go ahead and solve this one. And it's saying x minus 6. So I've just made a table, and I've given the values of x. And let's see what x minus 6 is going to be. So if I have x is negative 2 minus 6, what do I end up with? I'm going to get negative 8. I have 0 minus 6, I'm going to get negative 6. 1 minus 6, I'm going to get negative 5. So f of x minus 6 is all this that I just calculated. And I have negative 8, negative 6, and negative 5. And then it is saying that I need to calculate f of x minus 6, which is this, plus 3. So if I do negative 8 plus 3, what do I get? I get negative 5. If I do negative 6 plus 3, I get negative 3. And if I do negative 5 plus 3, I get negative 2. And so now let's look at my ordered pairs. My ordered pairs are negative 2, negative 5. I have 0, negative 3. And I have 1, negative 2. So looking at this, I am going to plot this now, and I'm going to use a different color. I've already plotted fx is equal to x, which is the parent the function, or the parent linear function. I've already plotted that here. Okay, and so let's see this. We have negative 2, negative 5. So this is negative 2, and here is negative 5. Okay. And then I have 0, negative 3, 0, negative 3. And I have 1, negative 2. So 1, negative 2. And so this is how my graph is moving. And I can see that this graph, as you can see, look. Here we go. And there is my graph. So even though it says minus 6, look what's happened. It shifted to the right, and then the plus 3 has moved it up. And that's basically what this entire lesson is all about. And I am just going to split it over here because we haven't even completed dilations and reflections. But right now we have just talked about translations, and so I think the video is getting pretty long, so I'm going to stop now, and I'm going to make a part 2 which will complete the entire unit on transformations. In the meantime, have a great day.